Okay, you have learned how to find the limiting reactant using the ratio of reactants. Now we are going to learn how to do a full chemical calculation based on limiting reactant. So for the first question, let's take a look. Sodium metal burns in chlorine gas to produce sodium chloride. The reaction can be expressed as the equation shown below. Okay, 2 sodium reacts with chlorine will produce 2 moles of sodium chloride. So 69 grams of sodium metal was burned in 48 dm cube of chlorine gas. Determine the mass of sodium chloride formed. So for this question, first we identified what are the information given. Okay, you are given 69 grams of sodium metal. So we'll take the ratio of sodium and compare it with chlorine. Okay, so you have a ratio of sodium is to chlorine. From the equation, the ratio is 2:1. Okay, so now that I know the ratio is 2:1, let me identify what is given in this question and what the question wants me to find. I'm given the value for the 2 reactants in this question. Okay, given for the both reactant, and I'm supposed to find the mass of sodium chloride produced. The mass of sodium chloride produced. So according to the 3-step approach that we learned before, the first step is to find the number of moles of what is given. To do that, I must recall the triangle from mole concept. Okay, so there are 4 different formulas for the mole concept. And since I'm given 69 grams of sodium metal, and to calculate the number of moles, I should use the formula number of moles equal mass over AR. And the atomic mass of sodium is 23, so the number of moles of sodium will be equals to 69 over 23. And this gives us 3 moles. Next, I will find the number of moles of chlorine. Since I'm given 48 dm cube of chlorine, I will use the formula number of moles equals to volume over 24. So for the number of moles of chlorine will be 48 over 24, giving me 2 moles. Now that I have the number of moles of both sodium and chlorine as the reactant, I will now compare their ratio. Okay, which is our second step of the 3-step approach. However, because we are dealing with limiting reactant, we need to break up. We will have a step 2A and a step 2B. So for step 2A, I need to find out which is the limiting reactant. To do that, let's consider the mole ratio between the 2 reactants again, which is sodium is to chlorine 2:1. Now that I've calculated number of moles of sodium to be 3 moles from my earlier calculation. So 3 moles of sodium will give me 1.5 moles of chlorine gas. Looking at the calculated value of 2 moles, I've calculated that chlorine, I have 2 moles of chlorine. But based on the ratio, I only need 1.5 moles. As such, chlorine is in excess. And if that's the case, sodium will be the limiting reactant. Let us now move on to step 2B. Knowing that sodium is a limiting reactant, we will use that number of moles to find our unknown. So our step 2B, okay, using the given and what we are going to find, which is sodium, which is the limiting reactant. Remember to use sodium as the given number of moles, and what we are finding is sodium chloride. So the ratio between sodium and sodium chloride in the equation is 2:2. Okay, 2 moles is to 2 moles. And from our previous calculation, so now that we know that there are 3 moles of sodium, that will mean that 3 moles of sodium chloride will be produced. Okay, once we know that there are 3 moles of sodium chloride produced, we can proceed with our third step, which is our final step to find the mass of sodium chloride. And using the formula, mass is equals to number of moles times mR, which is 3 times the mR of sodium chloride, which is 23 plus 35.5. And this gives me 3 times 58.5, which gives me the mass of 175.5 grams. And that's how we find our final answer.